In this problem, we're going to use the mass relations in a neutralization reaction. And the question is, how many grams of calcium hydroxide are needed to neutralize 25 milliliters of 0.100 molarity of nitric acid? So here we have two compounds. One is a base, one is an acid, and we need to determine how many grams of this we need to add to this solution to neutralize all the acid. So we have volume and we have also the molarity. And we have two different compounds. So that means that somehow at some point we need to use moles because the only way that we can transform from one compound to another one through the moles. Okay, so here basically, as I mentioned, the reactants are the acid and the base. The volume of and the molarity of nitric acid are given, and we are asked how many grams of calcium hydroxide are needed to neutralize this quantity of HNO3. So what will be the plan? We need to use the molarity and the volume of HNO3 solution to calculate the numbers of moles. Remember that molarity is moles over volume. So we have the volume of that solution. This is 25 mils of the HNO3. Okay, so by this we obtain, using those two information, we obtain the moles of nitric acid, HNO3, and then we need to transform those moles of HNO3 to moles of calcium hydroxide. And to do that, we need to look for the balance equation. So in a way to obtain that ratio between the moles of both of them in this neutralization reaction. And then once we have the moles of calcium hydroxide, we can calculate the grams of calcium hydroxide by using the molar mass of calcium hydroxide. So in other words, we have the volume and the molarity of nitric acid. We basically multiply this and we will obtain the moles of the nitric acid. Then by using the stoichiometry, okay, the ratio of moles from the balance equation of the neutralization of this acid, we're going to have that the conversion factor that will convert from moles of nitric acid to moles of calcium hydroxide. And once we have the moles of calcium hydroxide, we can turn to the mass of calcium hydroxide by using the molar mass of calcium hydroxide. So the product of the molar concentration of solution and its volume is going to be equals to basically 2.5 to power of minus third. Okay, and this will be the moles of nitric acid. By multiplying this, remember that we need to change the milliliters to liters so we can cancel with the liter of the molarity. Always the units of volume in molarity is going to be liter. Okay, so that's why we need to transform this milliliters to liters by dividing by 1000, and there we multiply this by the molarity and we will have the 2.5 times to 10 power of minus 3. Now that we have the moles, we need to look for the balance equation, that is this one. Okay, 2 moles of nitric acid plus 1 mole of calcium hydroxide will produce the 2 moles of water and calcium nitrate. So here we can see that the stoichiometry of this reaction is 2 to 1. 2 moles of nitric acid by each of calcium hydroxide. So that's the ratio that we're going to use here to transform the nitric acid to calcium hydroxide. So, as I mentioned, 2 moles of nitric acid is going to be equal to 1 mole of calcium hydroxide. Therefore, these are the moles that we calculated before. This is the ratio. This is from the stoichiometry. And once we have the moles of calcium hydroxide, we can multiply by the molar mass. This is the molar mass of calcium hydroxide, grams over mole, 74.1 grams over mole. So in that way we can cancel the moles of calcium hydroxide, and then we will have the mass of the calcium hydroxide that we need to add to the solution to neutralize all the nitric acid in that solution. So this will be 0.0926 grams of calcium hydroxide. So the answer is reasonable because a small amount of dilute acid requires only a small amount of base to neutralize it.